Legal&Tax is on a constant drive to educate all our staff and clients around numerous issues, including COVID-19. We were very fortunate to be invited to take part in a discussion with various CEOs and their companies, where Professor Barry Shube, chairperson of the Ministerial Advisory Committee on Vaccines, was a guest speaker. We debunk the myths around COVID-19 vaccines and provide you with insights into the third wave. This information is so important and relevant, and we are pleased to share this webinar with you. We hope you enjoy it.
So welcome everyone. Welcome to Professor Barry Shube, who I'm going to give a bit of a bio about in exactly 30 seconds. But I wanted to thank three people who were very helpful in putting this together: Kerrigan, Jerry, and Darren, who were all very helpful. And where this germinated from was my involvement in Business for South Africa. I've seen the tremendous benefit of having information, that all of this stuff can feel overwhelming and it can feel scary, and just having real experts to assist and guide us. And Professor Shube, who chairs the Ministerial Advisory Committee on vaccines, I've heard him, and he is a national gem. And then in discussing with Herschel, another national gem, Herschel Jarwitz, and Rafi Siegel, we thought getting our businesses together in whatever form. I know there's some call centers who are watching, socially distanced, but are watching, getting us all together to make the professor's time more useful. And so that's how we came. So we welcome everyone from Jarwitz Properties, everyone from the Advantage Group, Legal&Tax, and Wazipo Capital. Welcome everyone, and thank you so much for making the time. Professor Shube, to read his CV is a daunting task. But actually what I can say about him, knowing him and dealing with him, is that actually if I got it wrong, which I'm not so good at protocol, it wouldn't matter to him. And that's the biggest accolade I could tell. He is a unique human being, but he was a professor and head of the Department of Virology at WITS. As I say, he currently chairs the Ministerial Advisory Committee on COVID vaccines. He's been a member of a number of global health bodies. He served on WHO expert committees, been on the advisory to the Director General of the WHO. He was the founding chairman of the South African National Advisory Group on immunization. He's published 299 scientific publications. I'm sure that that's even changed. He's been given awards by the state president, the Paul Harris Award, the African Society for the Jewish Achievers Lifetime Awards, and the list goes on. And the truth is that he retired some time back and heard the call of the nation and came back and to assist us. So, Professor Shube, it's a great honor for us to have you here. And how is retirement going?
Yeah. Yeah. What retirement, as I said. Yeah.
Exactly. So, Professor Shube, before we go into the vaccine, which we want to spend the bulk of the time on a Q&A format, answers to people's fears, we're currently in a very scary third wave, and maybe you can talk a little bit about it and some things people can do to keep themselves safe.
Yeah. Well, first of all, thanks. Good afternoon, Benji and Herschel and Rafi. Thank you very much. I must thank you very much for giving me this opportunity to talk. Maybe just for 10 seconds, I can just say one or two words, because I think it's very important, because the problem with actually dealing with this epidemic is that it's really a partnership. It's a partnership between the professionals that we are and also the population. And it has to be a partnership, because we need to kind of get your trust, and you need to be able to believe in us. And unfortunately, there's a tremendous amount of misinformation, of wrong information, of outright completely wrong information, conspiracy theories, much of it propagated through social media. And I think it's just important, and it's an appeal to everybody, that you do need to check your source of information, that it comes from an authentic, scientifically evidence-based source. Because I say there is a lot of nonsense out there, and you can be kind of, going on the completely wrong path. Anyway, I had to say that. Yeah, where we are at the moment, unfortunately, we are, particularly in Gauteng, in a very sticky situation. We are certainly well into the third wave by all definitions of what a third wave is. And Gauteng is by far the worst province affected at the moment. It's unusual because the first and second wave started down from the Western Cape and then moved up. This started inland, actually started in the northern province, Northern Cape, and then moved down inland to the Free State, Northwest, and then Gauteng. So people in Gauteng really have to be particularly careful. Now, we are trying to roll out the vaccine rollout as fast as possible, but clearly we are way behind schedule. We can talk about that a bit later. But even then, people that have been vaccinated are not totally protected. I think it's an important thing. The vaccine is not 100% protective. So both people that have been vaccinated or people that have had COVID before, you must still view yourselves as being susceptible, as being that you still can get the infection. So you need to kind of, we keep on thumping on these, what we call them the non-pharmaceutical interventions. In other words, all these preventive measures to stop you getting infected. So it's wearing a mask to cover your nose, your mouth, and under your chin, must cover your nose, keeping a physical distance from people, generally avoiding social gatherings, particularly indoor gatherings, having adequate ventilation in rooms, and also sanitizing your hands, because your hands are the vehicles that do convey infection. So these, I think, are the ground rules. I think everybody knows them. And the problem is that, of course, people out generally don't see the consequences. This is a silent thing. They don't see the consequence of what infection can do. But you must really be aware that down the road from wherever you are, there are hospitals, and those hospitals are filled with people. I don't want to get too graphic, but I'll really cover a very, very unpleasant illness.
Right. Doc, thank you. I can say that we have heard from many of the doctors that it is in fact completely brutal at the moment. In fact, the doctor said to me yesterday that if he knew this was what medicine would be, he wouldn't have done medicine. One of the doctors in the front line. So your advice is go to work, come home, keep your things as minimal as possible, and follow the non-pharmaceutical advice and guidelines that have been in place.
Absolutely, sure.
And then, Doc, if you could just help us. We hear this word variant used a lot, and then we heard about this variant and that variant, and now it's alpha, gamma. Can you briefly just clear the mist about that stuff?
Okay, very briefly, this particular virus, it's called an RNA virus. RNA, as you remember, is the message in the genetic code. These RNA viruses, it's a long chain of RNA. When I say long, I mean you can hardly visualize under electron microscopes. Everything's very relative. But because it's a long RNA, it does tend to mutate. In other words, it tends to change, and it'll keep changing because the virus obviously hasn't got a brain, but under selective pressure, it'll try to evade the immune response. The immune response of people that have recovered from infection, or what we try to induce with the vaccine. So it is constantly mutating, it's constantly changing. And as it does so, it sets up a new line, what you call a lineage. And these lines are variants. They are variants, as the name implies, they're a variation because of mutation from the original parental or ancestral strain. So as we are vaccinating people, as people are recovering from infection, there is the pressure on the virus to change itself so the virus can escape this immune response. And it causes variants. There are variants throughout the world. The first variant which was picked up was actually picked up in the United Kingdom. And this variant, its characteristics are that it is very much more contagious, very much more infectious. But fortunately for them, it is still susceptible to the vaccine. That's what's called B117, or now what they call them alpha. I'll come just now to the terminology because people get a lot confused with the terminology. The second variant, and that variant is now the predominant strain in North America, in Europe, in Australia, and mainly the kind of developed world. The second variant is what we call the beta variant, and that's our variant. That's a variant which was first discovered in South Africa. It has spread to several countries in Africa, Southern African countries, and some Eastern African countries, one or two Central African countries. Most African countries don't have it as a dominant strain, but Southern African countries like Zimbabwe, Zambia, and so on, this is the dominant strain. 95 to 97% of the viruses are this beta variant. And that's very unfortunate for us. It's very bad luck for us because that particular variant is the most resistant to the vaccine of all the variants. The third variant is what's called the gamma variant, and that gamma variant is found mainly in South America. It's originally detected in Brazil, but it's spread to various other countries around there. So we're not too worried about it. It hasn't really spread very much outside that. And the fourth variant is a worrying one that's called the Delta variant, and that was first isolated in India. Now that variant is the most contagious of all, the most infectious, spreads the most rapidly. It's overtaken the original alpha variant in England, for example. Now what happens with these variants, as they change, as they mutate, they take on a new characteristic. And it can be one of three things. Either they become more contagious, or alternatively, they can cause more severe disease, or thirdly, they can escape the immune system. Our bad luck is the latter, is that ours is both more infectious, probably a bit more serious disease, but definitely more resistant to the vaccine. And therefore, that limits our choices with what vaccines we can use. So these variants, they started off with rather complicated numbers and so on. Now, our variant is called B1.351, or something called them Y501V2 and so on. So a lot of people started getting a bit confused. So the WHO said, let's make it a lot more simple. The first one in England and the developed world is alpha. Second one in Africa and South Africa is beta. The third one in Brazil and South America is gamma. And the one from India now is delta. And it actually goes on, carry on epsilon, chi, and so on, for the variants which are not such problematic. I think eventually they're going to run out of letters of the Greek alphabet. But so far we can focus on those four: alpha, beta, gamma, and delta.
And does that mean, Doc, and maybe the last question on this, is that what's driving that some of this reinfection of COVID, where we thought that we would be immune if we got it once, and people are getting it twice? And even saw a presentation by Discovery that they had 13 or 14 people that have got it 3 times.
3 times, correct. Yeah, exactly that. No, it's actually 2 things. One of them is the variants, because the variants change they change what we call the antigenicity, in other words, the characteristic. So if you had COVID in the first wave, you had COVID with one of the original, what we call ancestral strains or parental strains. The beta variant only came about in the second wave. So if you were infected in the first wave, you're completely susceptible to the beta variant in the second wave. So the variants do play a role, and the beta variant is now our dominant strain in the third wave as well. So that's one of the reasons. The other reason is that the immunity doesn't last all that long, unfortunately. And it's not complete, it's partially protective. In other words, it does protect against severe disease, but not against more mild disease. And that's why people are getting it second after, even sometimes after the vaccination. We know that a lot of people who've been vaccinated still get the illness, but usually it's very much milder. You see, the main point of the vaccine, what we really want to do is prevent severe disease, because it's severe disease which overloads the hospitals and so on. Mild disease, if it's very mild, of course, we can tolerate it. We all get the common cold, for example, the sniffles. That's not too serious. But the vaccine will not be 100% protective by any means.
Thanks, Prof. Prof, just before we get into the vaccine, just two quick questions. It would seem to be that a lot more younger people and children are getting infected in this wave and bringing it home. Is that correct? And is that because of this new variant, or is that just a perception that's incorrect?
No, I think it's a real perception. And certainly many of the clinicians are saying that, many of the doctors are saying that. They are seeing two things. One of them, that younger people are getting more involved, and also that there are very, very much these household clustering of cases. As a whole household gets infected. And previously it would be one or two in a household, but it wouldn't spread within the household. I think this is all a reflection of it being a much more contagious variant. So it's spreading more rapidly, and previously the younger folk were relatively spared, but now it is penetrating in a much wider population. Younger people are also getting involved. Fortunately, not as seriously ill usually, unless of course they've got some underlying illness, which makes them more susceptible, but generally not as ill, but certainly is spreading more commonly in young individuals.
And let's move on to the vaccines, which I know is your real area of specialty. So I wanted to just start off with, there's a lot of concern about the vaccine. As you mentioned, that there's mistrust for a whole host of reasons, but I think skepticism about vaccines hasn't only been limited to the COVID vaccine. I mean, there are a lot of people who are skeptical about even getting a flu vaccine. So if you can maybe just spend a few minutes telling us actually what is a vaccine and what is going into your body when you receive a vaccine, whether it's a flu vaccine or a COVID vaccine, and what does it actually do in the fight against COVID or even the flu?
Yeah. Okay, what a vaccine does is it tries to simulate what the natural infection would do. So let's take flu for an example. If you get influenza, you get a virus which goes into your body. Now that virus is foreign. It's foreign to your body. It's a foreign protein. So your body will try and fight it to get rid of it so that you can recover. And the organ in your body which does that is the immune system. The immune system's makes a protein called antibodies that protect you against getting infection. And there are also cells which allow you to heal, to recover. So when you get any infection, flu, COVID, whatever it is, your body's immune system, that organ, will fight that infection, enable you to recover. Now, what we do with a vaccine is try and mimic that. In other words, what you do is you take that foreign protein instead of the organism, because we don't want to make you sick with a vaccine. So we take simply that protein and we put that into the body. The body says, hold on, there's a foreign protein now. We've got to mount an immune response. So the body will then make antibodies, that protein, and also the cells will start being stimulated as well. Now then subsequently, if you do get exposed to the organism, now influenza, your body's already seen that foreign protein. So as it comes in, that antibodies will prevent you getting infection. If that infection does breach that first line of defense, then those cells will allow you to heal more quickly. So you'll get a much milder infection. So that's really what the vaccine does.
So when you have a vaccine, and people who've had the COVID vaccine sometimes are reporting mild symptoms, because a lot of people think, well, they have the flu vaccine, they end up getting the flu. They're going to have the COVID vaccine. They've heard that they get sick. What's happening to your body when you start getting the symptoms of the illness for which you've just been vaccinated? What's going on there?
Okay. What happens there is that your immune system is good, but it's not totally perfect. So it will do most of protecting, but some of that virus still does get through. But because you already now got your cells, which are already programmed for this particular foreign protein, and you've got antibodies, it'll allow you to heal better but obviously not 100%. It does also depend on how much, on the dosage of what's invading your body. If you get an overwhelming infection, a huge amount of virus, your body's got a limited, that immune system got a limited capability to fight that off. And therefore that virus is, we call it a breakthrough infection. As the name implies, it breaks through that immune defense. So unfortunately, look, some vaccines, like we look at measles, which you immunize, the children against. That vaccine is a superb vaccine. Polio vaccine, that's a superb vaccine. That's as close as 100% as you can get. Even then, not totally 100%, but that vaccine is very good. Then you come all the way to the flu vaccine. There we're looking at about 50 to 60%. Not that great. Measles vaccine, you're looking at 95, 97%. And it's a biological phenomenon. Without getting too technical, the measles virus itself lends itself to being protected by the immune system. When we come to COVID, we're like in between. Some of the vaccines, like the Pfizer vaccine, is pretty good. That's, if it's not for our variant, if you look at other variants, the United States, for example, those vaccines are about 95% protective. They're very good. We've got a problem. Our variant, because it's a tough little guy, our immune system is not so good at getting rid of it. So we come down to about, it's probably around about 65 to 70%. So about 2/3 of people won't get any symptoms, and about 1/3 will still get what you call a breakthrough.
And so, Bob, just leading on to that point, they talk about herd immunity. I know our President Ramaphosa spoke about, I think he used the term population immunity in addressing
Actually, synonyms. That's synonyms.
Yeah, the nation. What is herd immunity, and can it be achieved just simply because more and more people have got COVID and so they're more immune, or is a vaccination program and getting vaccinated essential to creating this population immunity that we're seeing as countries open up around the world after being vaccinated?
Yeah, no, I think you've actually explained it very well. Basically, if I can just take you slightly back, the rollout program is in 3 phases. The first phase was the healthcare workers, which is obvious. The second phase is the elderly and those who may have comorbidities, and the third phase is general population. So those first 2 phases are to basically minimize the effects of the virus. So in other words, if you immunize those people that have been immunized, we're trying to reduce their degree of illness so they don't go into the hospital and so forth. However, the virus is still circulating in the population. It's still infecting people. It's going from person to person to person to person. It's still prevalent in the community. And therefore, that's what I was saying right in the beginning, you still have to take precautions because that virus is very much out there. What we want to do then on the third phase is immunize as many people as possible. There are various ways of calculating, but it is a bit of a moving target because of the variants, because of the different efficiencies of vaccine and so on, because of people's behavior. But say, hypothetically, it's 2/3. If 2/3, that was the original calculation. If it's 2/3 of the population, whole population, that are immune to the virus, okay, that virus, as it were, hasn't got any more susceptible hosts to go to. It needs to have a certain number, a certain bulk, to enable it to continue circulating the population. In other words, once 2/3 of the population are immune, that poor little virus hasn't got much, it will never disappear. There's only one virus which we've actually made totally, and that's smallpox. Even the measles, they are there at a very, very low level. That's herd immunity. In other words, we now control it to such an extent that the virus is not circulating in the population, and then we don't have to take the precautions. So what we want to do, the aim of this whole immunization, is to convert this virus. At the moment, it's causing a tremendous amount of hardship, illness, mortality, unfortunately, and so on. We want to take this virus and convert it into the other. We do have other coronaviruses. They cause the common cold. Every winter, we all get the common cold, and we can tolerate that. That's not serious. The whole idea of the vaccine campaign is to convert this virus, the COVID virus, into one of these tamer, what we call endemic coronaviruses, which cause a common cold. Now, we don't have all the precautions that we do. That is herd immunity, when the whole population got a level of immunity to stop it circulating in the population.
So, Prof, we developed this vaccine very quickly.
Yeah.
Operation Warp Speed and those kind of things. And then we hear like things about J&J and parts of a Baltimore factory, and it makes us scared and nervous. Like, hasn't the speed in which this vaccine production or development, hasn't it made us, isn't this vaccine dangerous?
Yeah, Benji, I often get asked that question. And actually, the answer is actually the complete opposite. You should actually feel reassured because you've got a very, very stringent watchdog, which is making absolutely sure that the vaccine is safe. You know, vaccines are given to healthy people, whereas medicines are given to sick people. So those criteria of safety are much, much, much more stringent for a vaccine than they are for a medicine, for a drug. But even for medicines and drugs, there are stringent regulatory requirements, to be licensed. But for a vaccine, it's much, much more stringent. So any little safety signal, they will come down hard. And this goes all the way through when they do clinical trials. When they do a clinical trial to see, is a vaccine, a potential vaccine, is it effective, is it safe? And it goes through the clinical trial before it's licensed. Even then, there's an independent monitoring board, completely independent, which is it's a very vigilant watchdog. And any little safety signal, they'll close down the trial just to protect the people that are volunteering. And even more so, once a thing is licensed, there is there's a technical term for it. It's called pharmacovigilance. And as the name implies, they're vigilantly looking for any problem that has the vaccine. This is throughout the world. So internationally and also locally with our health regulatory body, they will constantly be monitoring for any safety signal. Now, what happened with J&J is that there was a fact, the raw material, we call it the active pharmaceutical ingredient, API. That gets sent to places like at Aspen, where they fill and finish. But the initial starting material was produced in a company in Baltimore called Emergent Biosolutions. And what happens is that how it happened, I'm not quite sure. They make both AstraZeneca and Johnson & Johnson, and the two got mixed up in the mixture. How it happened, I don't know. Now, immediately the FDA, which is the American regulatory authority, said, close the factory down. Those batches have to be destroyed. Something like 60 million doses went down the drain. Now, I think that's just a reflection of how rigorous the watchdog is. So actually the interpretation of these lockdowns and pauses and stopping should actually be interpreted as a signal of safety, of reassurance. Because 15 years ago, when we had measles vaccine, they weren't quite as rigorous as this. So we can be reassured that there's a vigilant watchdog protecting us. So people moan at the SAHPRA, which is the African Health Product Regulatory Authority. Why aren't they licensing this? Why aren't they licensing that? And it's really to kind of protect the population. And the more we advance scientifically, the more intense is that monitoring and the more reliable is the monitoring.
So, Doc, we've got two vaccines in the country, basically, at the moment. We've got the J&J and we've got the Pfizer.
Correct.
And they talk about it in there's different technologies that deliver it. And I don't think people are so, but is there any part of it that you feel one's safer than another? Let's go through those questions about the two. Is J&J safer than Pfizer or anything like that? The J&J one and then done, the one shot and then done, the Pfizer 2 shots. What is the difference between the two?
Okay, they are structurally different. The Pfizer is just the messenger RNA that I spoke about earlier. The J&J, they take that RNA and they stitch it into a carrier virus, another virus. That carrier virus can't multiply. It's just there to simply carry it into the body. So it's structurally a little bit different. Both of them are extremely safe vaccines, extremely safe, probably safer than many of the other vaccines that we give to children, for example. But they do have different side effects. The Johnson & Johnson was associated, you remember, with blood clots. The medical term for it is thrombosis, thromboembolic disease. But that is extremely rare. It was, the last count, I think, was 0.1 per million doses. But obviously for that, no, sorry, 0.7 per million doses, 0.7 cases per million doses. That's how it's calculated out to be. But obviously for that person, it can be quite serious. Fortunately, that disease is treatable, and we alert people that if they do have persistent headache or persistent abdominal pain, they must go for medical attention because it can be treated. But it is excessively rare, 0.7 per million doses. That's with the Johnson & Johnson. The Pfizer vaccine, the risk is there's a little bit of risk because of allergic responses to it. So they have had what you call anaphylaxis, which is the serious, where somebody collapses as a result of allergy. And that's about also the same kind of order, about 5 to 7 per million doses. And for both of those, you can have people that are very, very rarely allergic to these vaccines. And people that are allergic generally to bee stings or food allergies and that kind of thing, then normally when you get your shot, you say that you should wait for about 15 minutes for observation, just in case you have some allergic response. Somebody that has got an allergic propensity, they should wait maybe 30 minutes, half an hour, just for observation, just to make sure. But both are very rare side effects, I must stress, extremely rare.
And is one better than the other? Or do you take the vaccine in front of you?
Take the vaccine in front of you. Whatever vaccine comes, the most important thing is that you don't want to get COVID. So the earlier that you can get the vaccine, they are both very effective vaccines. They're both very safe vaccines. The important thing is to get vaccinated as soon as possible.
Doc, I feel like I've asked you this question on various formats numerous times, so I apologize again. There's so many different questions about what happens if I've got this or what happens if I've got that. And again, we advise anyone this is not specific medical advice. But is there any overarching reason why you can think why someone shouldn't have a vaccine?
The bottom line is no. I don't think there's any, we call it in medical terms a contraindication. In other words, that you against being indicating it. I don't think there's any individual that shouldn't. I think somebody that has had blood clots, for example, they would need to alert the vaccine so they can again wait for 30 minutes instead of 50 minutes. And they need to be aware of that. If they do get symptoms, they should alert the medical doctors. Pregnancy is one that comes up often. Pregnancy or women planning pregnancy. And the majority opinion is that should not be a reason not to get vaccinated. If it's possible to delay it beyond 14 weeks, maybe better. Just as for no medical reason, but just as a kind of precaution. If it's not possible, better to get vaccinated, because pregnancy itself carries a little bit of risk with COVID. So better to get vaccinated against COVID. So there's no individual reason not to get vaccinated.
Doctor, the biggest single question coming our way at work is around fertility and fertility issues. And as you said in the beginning, a lot of fake news around fertility issues for both men and women. Not only women who are planning on having babies, but men who also want to have start families and that they were concerned about fertility. What do you have to say to that? Like, are there any reports or findings that can show that this is not a concern worth not vaccinating about?
There have been quite a few studies now where they've actually looked at, for example, sperm counts. There's been a paper just come out now and showed there's absolutely no difference whatsoever. There's no effect on sperm counts in terms of males. And there've been one or two other studies on males.
Doc,
well.
you know, it's interesting. Sorry to interrupt you, but I read that study just with my limited chartered accountancy thing. And in fact, that study, and again, with my limited knowledge, that study said that actually there was more of a reduction in sperm from COVID than there was from the vaccine.
Oh yes. No, COVID itself. COVID can cause reduction of sperm count for sure. But the vaccine has not been associated with it at all. And you know, kind of biologically, there couldn't really be any way in which it could. We can't really think of a way. You know, the only kind of speculative thing is that maybe the antibodies would cross-react, but we know that they don't. In other words, that the antibodies that you're producing against the virus might have some effect against sperm, for example, spermatozoa, or in the case of women, the ova.
Or menstrual cycles. Have there been any changes to menstrual cycles or anything like that?
Absolutely not. There's no evidence whatsoever that the vaccine affects fertility either in men or in women. And biologically, we can't see how they could be. So certainly, vaccine is not a reason. It's not a reason to get vaccinated if somebody's planning a family.
Thanks, Prof. Just might be a little bit of repetition. I'm seeing some questions coming through, and really, I think what I think is really helping to do is just engender some trust in the vaccines. And there was a question to say that other vaccines, like you mentioned, smallpox, polio, took years and years, decades, and you know this vaccine was invented in months, and it would seem to be that a lot of the authorization, whether it be from the FDA or other regulatory bodies, has been in the form of, and I'm going to use inverted commas, emergency approval. Should we read anything into the fact that it's emergency approval, or is it the same process as it would be for normal, just expedited?
Now, I'm so glad you brought that up, because a lot of people seem to be worried about the terminology. Yeah, it's unfortunate that they use that terminology. It's called emergency use license or emergency use authorization, EUL or EUA. And it's really terminology, because basically the reason why it's given that term is that what they're doing now, because they're new vaccines, is that they're actually monitoring it. Now, normally what happens, you do the clinical trials, there's obviously the volunteers, and there's intensive monitoring. Then there's licensure, and then after licensure, there's called post-marketing licensure. And then they kind of look for, as I mentioned earlier, they look for various safety signals. Now, any medicine or any vaccine has to be, while it's being monitored, it's called emergency use licensure or emergency use authorization. They're really synonyms. And that's where that term is. In other words, it's not like, for example, measles vaccine. Nobody's really kind of actively monitoring the side effects now. That underwent emergency use authorization and then general authorization. The COVID vaccines at this particular time period is emergency use authorization, and then eventually get ordinary. Unfortunately, the term emergency seems to kind of get people a little bit rattled. It's just it's a time period, really. That's why it's got that term.
And Prof, just in terms of the ordering of the vaccine, so the health workers, then the elderly above the age of 60, and then moving in, are we working according to international guidelines or accepted norms about prioritizing the vaccines, or is what we've chosen unique to South Africa and our circumstances?
No, not at all unique. No, universally throughout the world, it's stratified by age. Age is the major determinant of the severity of illness. The older one is, the more likely one's to get more severe illness. That's universal throughout the world, all countries globally, and all countries have prioritized age. Where there's a little bit of deviation from that is that we actually, as our MAC, we wanted to also include younger comorbidities, the severe comorbidities. The problem is it's an administrative problem to kind of, get the criteria for what is severe and what's not severe, because obviously there's a gradation of blood pressure, there's a gradation of diabetes and so on. So the kind of verification process. So what the Department of Health have done is they've done it strictly on age, 60s, 50s, 40s, and so on. There is some logic to that, because if you look at the 60 pluses, more than 80% of the comorbidities, which are, in other words, underlying illnesses, which put a person at risk, are likely to be in the 60 pluses. And then another big percentage, 50 plus. And as you go down in age to young individuals, you get far less comorbidities. So there's some logic to that. The only problem, of course, there are outliers. There are young people with severe comorbidities, which are unfortunately escaping that net. We're trying to work again to try and get a mechanism to include those in the age stratification. As it stands at the moment, it is purely on age, together with some occupation, like, for example, the teachers are being immunized now, and then it's going to be police and security personnel, because they are key to the economy as well as being at risk. And obviously the healthcare workers were the occupational right at the beginning.
Prof, can you just give us some just broad direction in terms of, I think comorbidities also, certainly I hadn't heard it prior to COVID. What would be some of the comorbidities? If you suffer from these conditions, you really need to be vigilant with regard to your health.
Okay, I mean, other than age, of course, is the dominant one. Diabetes is an important one. High blood pressure is another important one. Pathological obesity, in other words, the BMI over 30 plus is a risk factor. Chronic renal disease, chronic kidney disease, cancer, of course, or anything that suppresses the immune system. HIV would obviously be one, although HIV doesn't seem to be such a major one, but unless obviously it's more advanced. Those are the main, what we call comorbidities. In other words, illnesses which make you predisposed to more severe disease. Those are the main ones.
Prof, one or two questions that are coming through, just in fact, a few questions. Do we know anything about the potential long-term impact of the vaccination, number one? And is it likely that, similar to the flu shot, that we will have to continue to have vaccinations on an annual basis in order to really keep this COVID-19 at bay for an extended period of time?
Yeah, Herschel, I'm glad you asked the one about the long term. And the reason I'm glad you asked that, because one of the fake news, and it's amazing, this was actually fake news which is propagated by a person by the name of Luc Montagnier. Luc Montagnier is the Nobel Prize winner who discovered HIV in 1983. And for some odd reason, he's kind of gone on record as saying that 20 years down the line, people are going to die because of the vaccine. Now, there's absolute nonsense. It's rubbish. There's no basis. Why these people, I'm saying that sometimes these fake stories come with quite an important stamp on them. And you just got to always be very careful with, to evaluate it. In terms of long-term problems with the vaccine, we've had so many human vaccines. I don't know, we're probably now about 40 or 50 vaccines, which are routinely given to human beings or given to travelers and human beings and routine immunization. And, there's been a lot of experience looking at long-term effects of vaccines. And all vaccines that have been monitored, and it's a large number of them, obviously, and millions or billions of people have been vaccinated. Any side effects of vaccines, and some vaccines do really give side effects, always occur within about 4 weeks. So if you have no saying within about 4 weeks, you're never likely to get any problem from the vaccine. And there's no vaccine which has given any long-term effects. And it's extremely unlikely. I mean, it kind of defies how you can actually conceive of how these COVID vaccines, which are bits of RNA in a carrier inert virus, how that could conceivably give you long-term things. So the answer to your question is biologically, observationally, there's no long-term danger of these vaccines. With regard to boosting, there probably won't be a need to boost for 2 reasons. One of them is that the vaccine it's not like measles vaccine again. Measles vaccine gives you years and years and years of protection. This is not likely to do that. It's not the same powerful immune stimulant. And that vaccine-induced immunity will probably wane, will decay after a while. How soon, we don't know. It's too early to tell. But probably over a couple of years, we will probably lose that immunity. That's the one thing. The other thing is that more and more variants will be generated, which may escape the vaccination. So the probability is that we will need boosters. Now that we don't know, will it be annually? Will it be every 2 years? Will it be every 5 years? That we don't know as yet. It's too early to tell. But there probably will be some boosting necessary.
Prof, they tell us that a question coming through is that once you've had the flu vac, you should wait a bit to have the COVID vaccine. What is that time period that you should wait?
Yeah, we advise at least 2 weeks, maybe 4 weeks, but at least 2 weeks after the flu to get the thing. But again, if there's pressure, if you don't want to kind of lose out on the COVID vaccine, you can have it sooner. But ideally, at least 2 weeks.
And if you've had, someone asked if you've had COVID, should you wait to have the vaccine?
Yeah, then it's about 4 weeks. You should wait at least 4 weeks. Yeah.
So there's a question that says, does RNA affect your DNA?
No.
Okay,
Cannot.
we can move.
Cannot.
Fine. Then there's lots of talk about some of the other vaccines like Sputnik and Sinovac. What's your advice on those? If SAHPRA approved, take it. If they don't take it.
If SAHPRA approves vaccine, take it for sure. But I don't think SAHPRA is going to approve it very readily. The problem with that, look, I must say that, and AstraZeneca as well, and Sinovac, and BOS, and Sputnik are good vaccines. Let me start with that. They're not nonsense vaccines. They're good vaccines. They've worked very well overseas. AstraZeneca is used widely in the United Kingdom. Sputnik is used widely in many, I think about 60, 70 countries. Sinovac similarly, and it's brought down the thing quite markedly. Our problem is the variant. That's the problem. That beta variant. That limits our choices to 2, Pfizer and Johnson & Johnson, which we know it does work. With the other vaccine, we don't know it's going to work.
Let me just the question there. Sorry, Mitch. Just originally, I think the waiting period from the first Pfizer vaccine to the second was originally set at 3 weeks, and now it seems to have extended to 6 weeks. Yeah. Is there any specific reason, and is it better to wait the 6 weeks? And if you have the second vaccine slightly earlier than the 6 weeks, would that impact on the how effective the vaccine is?
Yeah, that the 3 week delay between the first and second dose was calculated from the trials. When they originally did the clinical trials, the evaluation, they did 3 because they actually wanted to get the vaccine going. So they made a 3 week delay. And that is what is registered by the FDA in America. That's what the regimen is in America. in many other countries, in Israel and countries in Europe, and that they use a 3-week because that's what the trial said, that's what the FDA license and so on. Then the United Kingdom decided, for purely practical reasons, because they want to get more people immunized as fast as possible, to stretch that first dose, they made a 12-week interval, 12 weeks between the first and second dose. And that's not unusual. You know, just as a side, our hepatitis vaccine, we do 6 months. Our papilloma, the wart vaccine, we do 6 months as well. So a 12-week delay is not too unusual. And then they noticed, in fact, that the immune response is actually better. If you had a delay period longer than the 3 weeks, then you know, and that's why United Kingdom, they got 12-week delay. The disadvantage of 12-week is that you have a lot of drop-off. Now, it's a long time to wait 12 weeks from your first dose to your second dose. People sometimes forget, they don't bother to come back for the second dose, and so on. So it's a lot of drop-off. And in this country, drop-off is a bit of a problem. So we decided to kind of get the best of both worlds and make it 6 weeks, 42 days. So you get that added distance for a good immune response, but you're not then risking people dropping off. That's where that came from. But you get a better immune response. The third thing, you know, if by any chance there's a reason why you need to get it earlier than 6 weeks, well, you can always fall back on what they do in America and in other countries where they do 3 weeks. Certainly, it must never be less than 3 weeks. 3 weeks is a minimum, but ideal will be 6 weeks.
Doc, there's lots coming through about some findings that actually combining, I know the J&J is meant to be a one and then done kind of vaccine, but topping up the J&J or if we use the AstraZeneca because of that kind of technology with a Pfizer, that gives a very good immune response. What's your view on that?
Yes, no, there's a lot of work on that. You know, the one dose for Johnson & Johnson was really worked out from the trials where they showed that the immunity after one dose was very good for many, many months. And that's why they decided just to do one dose. But obviously, if you have a boost, that will boost the immune system. So there's been a lot of work now, mainly with the Johnson & Johnson. There has been a paper with Pfizer, but of course, with AstraZeneca, but we're not using AstraZeneca. But if you do a boost with Pfizer after Johnson & Johnson or after AstraZeneca, you get a very good immune response. And mixing the vaccines seemed to kind of be quite a good thing to do. So that at the moment is still being researched, but there's a lot of kind of indication that may well give you a very good response. So we are thinking of boosting the healthcare workers who got the Johnson & Johnson probably after about 6 months.
If you've had COVID, how long should you wait, or how long do you need to wait before either you get your first vaccine, or if you've had your first vaccine and then unfortunately contracted COVID, how long should you wait for the second Pfizer vaccine if you've had the Pfizer?
Yeah, we say at least 4 weeks. At least 4 weeks. But
even in between the two. Even in between the two. You have one Pfizer and then you get COVID.
Yeah, I think always 4 weeks after the COVID.
Fine.
After you recover from COVID. Yeah, that's our recommendation. At least 4 weeks. Look, nothing is totally iron cast. You know, if for any reason there's tremendous pressure, then 3.5 weeks, but the ideal is at least 4 weeks. Longer than that doesn't really matter. But we don't want to make it too much shorter than 4 weeks.
Prof, there's quite a few questions coming at the end about this person running around in COVID circles by the name of ivermectin.
Yeah, I knew that was going to come up, Herschel. Eventually, it's going to come up.
Yeah. So maybe if you could just give us your insights into it, and you know, if people have got access to ivermectin, should they be taking it, and just whatever your view is on ivermectin.
Look, ivermectin was a drug which was designed to treat worms. It was originally a drug used for treating a disease called river blindness in human beings. Now that's a worm infestation, occurs in Central Africa and to some extent West Africa. We don't get it in this country at all, zilch. There's also a topical, like a paste used for treating scabies, the ivermectin. Those are the only situations where ivermectin's got any benefit at all. And there have been lots of trials. Some of the trials, unfortunately, where they say that it has worked, have been very, very small trials, poorly controlled. The bottom line of a long story is there's no evidence. There's no evidence that it does anything other than for river blindness, but nothing for COVID. There's no evidence that it has any effect for COVID. And it's not totally innocuous. It's not totally safe. If it's taken in small doses, it probably won't cause too much harm. But in larger doses, it can cause harm. It's caused blindness. It's caused liver, kidney failure, and caused one or other two serious problems when people take it in high doses. But really, there's no evidence that it works at the moment, and it's been very intensively investigated throughout the world. No licensing authority in the world will say that it's got therapeutic benefit.
Prof, we're coming to the end, and this hour is absolutely flown, and we thank you so much, and it feels like we could have another 10 of these. But if you had one thing to say to an anti-vaxxer, and you've got them listening to you, and it's not from some crazy political or whatever, they're just anti-vaxxers, what do you have to say to them in terms of us ever getting back without masks, having sporting events that have people? What would your plea be to them as a final plea?
All right. I think there are two types of people that don't want vaccine. They're the anti-vaxxers who listen to conspiracy theories. And conspiracy theories come from science fiction. Now that Bill Gates has implanted microchips to kind of keep tabs on you. I mean, that is obviously, it's as much chance as you going to Alpha Centauri galaxy, in space travel. It belongs to the same kind of ilk as that. It's completely science fiction. And people dream up these conspiracy theories which have got no semblance of reality whatsoever. Those are anti-vaxxers. Unfortunately, anti-vaxxers tend to be resistant to any kind of reasonable discourse. Then you get a large bulk of the hesitant people, and they've got a legitimate concern. They're legitimate. They want to ask questions. They need to ask questions. And I think we just have to kind of basically tell them the facts which are scientific facts, not the facts which come on the social media and on Twitter and so on and so on, but well-founded facts that these vaccines now are probably the safest of all vaccines which have ever been developed. So you really can be reassured, as I mentioned earlier, that the watchdogs are so rigorous that the safety profile is so great that you really can be reassured. And I think people that are hesitant, often their hesitancy falls away when they see that their neighbor or their relative or their friend gets vaccinated, and they're protected against a disease which is causing a lot of kind of illness, serious illness and mortality. And we've got a vaccine which now does protect. So don't hesitate.
Prof, I just want to tell everyone that the Prof wouldn't take any money for this talk or for his time, and asked if we suggested that if we wanted to make a donation to an incredible organization called the Angel Network, which each of the businesses have done or will be doing. And just to say, this time has been really so insightful and enlightening. I know I haven't even asked you this, but I think I've got to know you, that if we've got any other questions, I know you're available. You make yourself so available. So I just say to everyone from any of the organizations, reach out to Hirsch or Raf or myself, and let's work together, because you know, you can see the kind of brilliance leading our country and hearing the call of the country, and let's work together to get everyone vaccinated. Prof, I don't know if you've got any final or things, or maybe Hirsch, and then Prof, you'll close it off with any final thoughts.
Yeah, Prof, I just want to say thank you so much for giving up your time. I just want to just ask one last question. If you could prioritize in terms of, it seems like the emphasis is always on wear a mask, but it's my understanding that in actual fact, social distancing, sanitizing, and being in places where there's airflow are actually more important in trying to contain this virus without the vaccine. Is that correct? And you know, masks are important, but stay apart.
Yeah, Herschel, I think all these things are important, and it's difficult to kind of rank them. I think what they have conclusively shown in many studies, rigorous studies, that masking is not 100% effective, but is very effective. And you can see it on individual studies, on population studies, where they've introduced masks, mandatory masking, how the incidence has dropped precipitously. And they've shown this in a number of countries in well-conducted studies. So masks, provided that they're worn correctly, particularly covering the nose. Now, often you see people when they drop or they can't hear you, they pull the mask down. That's precisely the point, that you don't want to have a mask when you're talking to somebody. So, you know, I think that it is, I think all those are important. The mask, the distance, the ventilation are all important.
Thanks so much for your time, and more importantly, thanks for your service to our country and everything you've done to navigate us through this immeasurable human crisis.
No, thanks, Herschel. I think maybe on my last final word, it's a plea to everybody that there's a lot of, as I started off saying, let's not conclude with it. There's a lot of misinformation, there's a lot of mistruths. Some people are mischievous, some people are just born out of it. And unfortunately, journalists are often to blame as well. Please check where you get your information, that it comes from a good, authentic source, because there is a lot of misleading information out there. And that's a problem. It's a problem we're constantly dealing with, and for various reasons. And it doesn't really matter if somebody's got a doctor or even a professor behind their name. You must just check where your information comes from. And it's a partnership. It's the community and it's the professionals to control this disease. And thank you very much for giving me this opportunity. I appreciate it.
Thank you. Please all get vaccinated. Reach out to us if you have any further questions around the vaccine. And thank you all for your time.
Thanks so much, Benji. Thank you for your time. Thank you.